Hi, Math 95. So I wanted to go through the different examples in the notes that we did not do in class. Depending on which class you're in, if you were in the first class, I wrote it on here. If you were in the second class, as you know, there were some technical difficulties with trying to get people in the room and on Teams to see the same thing, and I wasn't able to write it on the PDF like this. And I had erased some of it before I realized that. So if there's some in here that's not done, I'll kind of have to remember just from memory which ones we did in class, but if I'm not sure, I'll just go ahead and do it again. So some of these you may have done in class, but I'm going to do again. All right, so we know that chapter 8 was about polynomials. We started out with adding and subtracting. We add and subtract like terms. Those are terms that have the same variables raised to the same powers, and our exponents do not change. So we look for like terms, like we see in example 1 and 2 here. So in example 2, for example, I know we did in 1 in class. So we look at here, we have x to the 5th. There is no other x to the 5th term, so that's just going to stay as it is. Now I can either just go in order here, or I can look for the next exponent down. That will then put my answer into that standard form that we want. So I'm going to look and say, okay, I have a plus 2x to the 4th minus 1x to the 4th. So 2 minus 1 is 1x to the 4th. We do not have any x to the thirds. We do have x squared, so 5 minus 7 is minus 2x squared. And then finally, I have negative 6 plus 2 is negative 4. Okay, I've combined all that I can. These cannot be combined because they're not like terms. All right, we did the next one in class, and I think we did example 4 in one class, but not the other. So example 4 we did in one class, but not the other. So let's go ahead and do it. So we have this polynomial, and we're subtracting one and adding one. So we said we can either just work through that subtraction sign, or if we want to rewrite it, we would leave the first one the same. We would change this subtraction to an addition, and then we'd change the sign of everything after that. So minus 4y squared plus 5y plus 5. Then since this part is being added, we can leave that just as it is when we take the parentheses away. Okay, so now I'm going to just look for like terms again, just as I did before. So let's say we have 9y squared, we have minus 4y squared. Those are our two y squared terms. So 9 minus 4 is 5y squared. Then I have negative 11y plus 5y plus 11y. So negative 11 plus 5 is negative 6. Negative 6 plus 11 is going to be 5, positive 5, so plus 5y. And then I have 12, 5, both positive, 12 plus 5 minus 14. So 12 plus 5 is 17. 17 minus 14 is plus 3. So there's going to be my answer for that one. Hopefully addition and subtraction are pretty familiar to you. Can remember them. You know, it's not a lot of rules you have to remember there. Moving on to multiplying, this is where we're going to use our product rule from the exponent rules. So that's this right here, right? We are going to add the exponents when we multiply these terms. Every term in the first polynomial gets multiplied by every term in the second polynomial. I think we did this first one together, but let's just go through it again for review. So here, my first polynomial is a monomial. It's one term. So it's going to multiply all the way across. So we have negative 4x times x to the third is negative 4x to the fourth. Negative 4x times 9x squared is minus 36x to the third. Negative 4x times negative 7x is plus 28x squared. And negative 4x times 11 is negative 44x. Okay, I've multiplied this outside term by every inside term. I have 4 terms in my answer, and I can't combine those anymore because they're not like terms. They all have different exponents. Okay, example 6 we did not do. Oops, hang on here. Let's go. Oh, where are we? All right, there we go. Let's try this again. So let's go down here to example 6. We did not do example 6 the other day. So we have to think about either FOIL in this particular case, or the expanded form of that is just thinking that every term in the first polynomial gets multiplied by every term in the second polynomial. So 2x gets multiplied by 5x, 2x times 3, and then negative 3 times 5x, and negative 3 times 3. So 2x times 5x is going to be 10x squared. 2x times 3 is 6x. Negative 3 times 5x is negative 15x. Negative 3 times 3 is negative 9. Then I do have two like terms here. So I can combine those and say 10x squared minus 9x minus 9. We did do example 7 in class. You can look at the completed notes for that, but just remember that when I square something, it means I have to multiply it by itself. So I multiply this by itself. I have to write it out like that and then go ahead and multiply it. I can't just square the first and square the second. So if I go on to example 8, you will see this also. When I have something to the third power or the fourth power or whatever power it is, I'm going to take that term, multiply it by itself 3 times. So I can only actually do the multiplication 2 at a time though. So I'm going to choose 2, multiply them first, and then multiply that answer by the third one. So again, I'd be multiplying first term and this one by each of those, and then the last term in this one by each of those. So 2x times 2x is 4x squared minus 2x, and then this gives me another minus 2x. Negative 1 times negative 1 is plus 1. Now, I like to clean this up a little bit and combine the like terms here. So I have 4x squared minus 4x plus 1 times 2x minus 1. So 4x squared times 2x is 8x to the third. 4x squared minus 1 is minus 4x squared. So this 4x squared got multiplied by both of these. Now it's this one's turn. So negative 4x times 2x squared is negative 8x squared. Negative 4x times negative 1 is plus 4x. 1 times 2x is 2x. 1 times negative 1 is negative 1. So we have 8x to the third minus 12x squared plus 6x minus 1. Now here, it didn't matter which 2 I did first because they're all the same, but if you were multiplying 3 expressions that were all different, it would not matter which 2 you did first. You could do the first 2 first, you could do the last 2 first, because the commutative property tells us the order does not matter. All right, example 9. So again, now I just have 2 terms here and 3 terms here, so each of these gets multiplied by each of the terms in the second expression, okay? So 8 times 3, we have 24a to the 10th. Remember, I multiply these expressions, that means that I am adding the exponents. Plus 16a to the 7th, minus 32a to the 5th, minus 30a to the 6th, minus 20a to the 3rd, plus 40a. Now I look at this and I actually do not have any like terms, just the way that the expressions, the exponents ended up, I don't have any like terms. The only thing I can do is these two are actually out of order for standard form for going from highest to lowest exponent. So I can change this to 24a to the 10th plus 16a to the 7th minus 30a to the 6th minus 32a to the 5th minus 20a to the third plus 40a. So this would be in standard form. Okay, so I know we talked about dividing a polynomial by a monomial. We did both of those in class. We talked about long division. Here's where I had not divided, so we can kind of see what we did. So we have to do number 13, and that is all. All right, so when we are doing these, right, we're doing long division. Now, this particular example, number 13, we could do a synthetic division once we know that now, but we can do it either way. So in this particular case, when we were looking at it, we were practicing long division, so that's how I'm going to do it. So I'm going to write out my, write in my long division here. If I look at this, I have x to the third, x to the second, x to the first, and a constant, so I do not need any zeros as placeholders. And I have x plus 3 out here as my divisor. So remember, I look at the leading terms. X times what is going to give us x to the third? Well, x times x squared. Or you could say x to the third divided by x, 3 minus 1 is x squared. Now I multiply this x squared by both of these. If you need it written out, you can think about it like this. X squared times x plus 3 gives me x cubed plus 3x squared. That's what I'm going to put here. Because there are two terms, I have to put it in parentheses and subtract. 8 minus 3 is 5, so 5x squared. Okay, so we look at like terms again, now that we have this part down here. Or sorry, leading terms, not like terms. Then we decide how many times does x go into 5x squared? What needs to be here? So x times something equals 5x squared. That something is 5x. We multiply 5x by both of these terms. 5x times x is 5x squared. 5x times 3 is 15x. We're going to subtract both of these. 17 minus 15 is 2, so we have 2x plus 6. And for the last time here, we look at the leading terms. X times what is going to give us 2x? That would be 2. 2 times x is 2x. This first term should always cancel out, so it should always be exactly the same. 2 times 3 is positive 6. I put these in parentheses, I subtract, and I end up with 0. So this means my quotient is x squared plus 5x plus 2. My remainder is 0. So, oops, not x to the 5th, huh? So if it asks you for the remainder, you can put 0. If it just asks you for the answer, you don't need to include the remainder when it's 0. So your quotient is x squared plus 5x plus 2. Just a reminder that if you want to check it, you're going to multiply your quotient times your divisor. Okay, use your multiplication rules. If you have a remainder, you need to add it or subtract it if it's negative here at the end to make this get back to what you started with. But since I have a remainder of 0, I won't need to do that. So if I multiply x squared times x, I'd get x cubed. X squared times 3 is going to be 3x squared. Then I multiply 5x times both of those. So 5x squared plus 15x. And finally, I multiply 2 by both of these. So I would get 2x plus 6. So x cubed plus 8x squared plus 17x plus 6. You can see that's what we started out with, so that does check. Alrighty, so that is the end of the notes, the examples that we hadn't done in class. So if you have any other questions, let me know. And I also have another video that I will post that does the synthetic division problems that were in the separate set of notes that we did. All right, and have a great day, and let me know if you have any questions.